In this video, we're going to be looking at question 7, part A and B, and question 8, because they both deal with the same scenario. So, starting off with question 7, we're looking at the vertical components of the four vectors, vector A, B, C, and D. So we're going to use a bit of trig. We're going to remember these little guys. Some old hags can't always hide their old age. And we're going to use that to break up particularly vectors A and B, because obviously C and D are already on those horizontal and vertical axes. So let's take vector A to begin with. Vector A, like that, it's going to have a horizontal component, A sub x, and a vertical component, A sub y, and it's going to be 5.66 newtons long, and it's going to be at a 45-degree angle here. So I'm going to want to use sine, because it's using this angle here to find the opposite using the hypotenuse. So I'm going to say sine 45 is equal to the opposite over the hypotenuse, that is AY over 5.66. Now obviously I'm going to simplify that by multiplying both sides by 5.66, and I'm going to wind up with AY equals to A sub y equal to 5.66 sine 45. Once I plug that into the calculator, that will give me an answer, which gives me my my value. So that would be, I think, 4 newtons, 4.0 newtons. And I'm going to write up, because obviously it has a direction. So that's our first one. Then we're going to do the same thing basically for B. B obviously acting out like that at 30 degrees. It's 5 newtons, 5.00 newtons. I know my 5 doesn't look much like a 5 there. And so it's going to have this smaller, what do we got, B sub y. We'll just remind ourselves that that's B sub x there. And we're going to use the same sort of math that we did a minute ago. So again, sine 30, sine equals opposite over hypotenuse, which would be B sub y over the hypotenuse, which is 5.00. And then by simply rearranging, multiplying both sides by 5, we get B sub y. B sub y equals 5 times sine 30. So again, all we can do is plug that into the calculator and it'll come up with an answer for us, which I think should be around about 2.5 newtons. 2.5 newtons. And again, that'll be in the up direction. So the next part of the question, when we look at B, question B, says, which way will it move? Well, to work that out, we're really looking at a sum of forces. So I'm going to say a sum of the forces in the y direction is that we've got AY plus BY plus probably DY. Because remember, this was C over here. I had A, B, C, and D. C we can ignore because it's horizontal. So I'm going to go ahead and add these together, and I'm going to say upwards is positive for me. So I'm going to say 4, which was AY, plus 2.5, which was BY, plus, and then I'm going to have a negative because part D, this guy here, is a downwards vector. So I say minus 6.5. And what you'll find is if you add 4 and 2.5, and then you take away 6.5, it equals 0. Therefore, it will not move vertically. However, we can probably tell, based on the fact that vector C is quite big compared to the horizontal components of A and B, that it will move to the right. So we can work that one out. Question 8 then is asking us to look at the total force acting in question 7. Now we've already established that in the vertical axis that's going to be 0, which we did in question 7 part A. So now we're going to have to look at just the horizontal forces. So we've already got vector C solved for us. We're now going to go ahead and use the same technique we did in the couple of slides previous to work out the horizontal component of each of these vectors. So vector A, again, we're going to have A sub x. Now, and we're still going to have 45 degrees here. So now, using SOHCAHTOA, I would be inclined to use cos. So that means I'm going to have cos 45, being 45, it doesn't make that much difference, but cos 45 equals the adjacent, which is going to be A sub x, over the hypotenuse, which is 5.66, and then we're going to simplify it the same way we did before to give us a sub x equals 5.66 cos 45. So that gives us that. And then we're going to do the same thing with b, where we go like that. We call that 5.00 newtons. We're going to give it a horizontal component, which would be b sub x. We're going to whack in our 30 degrees, and we'll use the same technique that we've just used to give us an expression that says b sub x equals 5.00 cos 30. So now all we have to do is evaluate a sub x and b sub x, and we'll sort of add those together along with c. So that means that the sum of the forces in the x direction is going to be equal to, let's say, a sub x, remembering that this one will be negative because it's acting to the left, minus VE, I don't know why there's a G there, let's ignore that. Negative, where are we, plus b sub x plus c, which again doesn't need to be separated into its x and y. Now I haven't got a calculator handy, so I'll let you do that step, but hopefully that's helped you out. If there's any other questions, feel free to ask. Cheers.